EXPREG, which stands for exponential regression. So we're going to press enter to exponential regression, and there it comes. Now essentially that's our model. This r squared value is pretty good. It's up above 0.9. In fact, it's above 0.95, which is pretty excellent, actually. Pretty good fit. So we want to check the fit with the picture. So how can we do that? It's pretty easy. We got to go to y equals, clear out what's there, and then we have to insert the regression equation. So how do you do that? You go up to vars, and then you go down to statistics. You press enter. You go to the right to equations. You choose the regression equation, REGEQ, and it inserts the regression equation in there. Okay? It's kind of hard to see the regression equations because it's got so many decimals in it. So how about if we change that to a 7 and delete out those? And we can also delete out, oh, let's see, that'd be a 1, and then I can delete out the rest of these. Okay, that makes it just a little bit easier to see the regression model. So if everything's groovy, we press the graph key here, and there the model goes through. So you can see it's not a perfect fit. Up here it looks like it's diverging. Down here it looks pretty good. So it's hard to say whether using this as a predictive model is going to be great or not in the future. But okay, the r squared value was high enough. It fits decent enough. So what are we going to do with that? Well, I think we should write the model down. So if I quit out of there, I can see my regression data right there. So let me scoot this to the side, and I'm going to write it in. What does it look like? Let's see, if we use P for population, then we have P of T is equal to 7.87, if I do some rounding, times 1.019. 1.019. Well, let's round that up to 1.02 raised to the t. Right? So there's my model. There's part of the prediction. Now, because I've already put the regression equation into y1, I can already use it to determine these guys. So how am I going to do that? Well, it's backwards. I could actually do this by hand if I wanted to, but I think what I'm going to do is use either Solver or a graphing utility to do this. So what if I try to do it graphically? What would that look like? I put a line at 500, at 500, that's right, okay? And I better increase my window here a little bit. So I'm going to take my window up to 700, and I better scoot this thing out to graph more of it. So let's see, instead of 220, we gotta go to like 300, which would be the year 2100. So let's graph that and see what happens. Okay, so there's my intersection. All I do is got to do second calc, intersection, and this is really easy. Enter. Enter for the second curve, enter for the guess, and there, it just jumped on it. So it looks like 211. 211, what would that be? 211 would be, well, 200 is the year 2000, since we started in 1800, right? We started in 1800. So 211 is the year 2011, we would be up to 500 million. 500 million. What about a billion? That's the same as 1,000, right? So we could play the same game if we want. Maybe that's the easiest. I got to change the window. I better go out even further. How about another 100 years? I better do what? I better go above 1,000 here, so how about 11? Change this to 1,000. Now if I graph it, what happens? There's my intersection. Second, calc, intersect, enter, enter, enter. And it predicts what? 246. So let's make it 247. So what would that be? The year 2047. 2047 would be 1 billion. Okay? So we could probably double check and see, did the United States end up at 500 million in the year 2011? Well, you know, we're not quite there yet. We still got 3 years to go. Be curious to see what the data is for later, if the model is over-predicting or not. You can kind of see in the graph here, you can see that the model seems to be, the data seem to be slowing down, but the model is taking off. So it's not clear whether that's the best regression model or not. But we could try other regression models. For example, we could try the logistic one, but that would be another video.